Let's go ahead and start learning how to solve the matrices. You can use a graphing calculator for this, such as the TI-84s that we use in class, but today we're going to use a calculator in Desmos. So we'll navigate there in a little bit, but the first thing that we need to do is go ahead and get these matrices written so that we know what input to put into Desmos. Let's take a look at this first one. Glancing through it, I can see that I am in standard form, so I'm just ready to write my coefficients and constants. 2, -5, 1, -5, -3, 4, -2, 1, 6, 1, 4, 7. Before I switch to Desmos, I want to go ahead and do the rest of these so that we only have to switch back and forth one time. Let's also note that this is a 3x4 matrix. We're going to need that input into Desmos. Let's look at number 10. Glancing through these, I can see that those are also in standard form, x's, then y's, then z's, constants on the other side. So we're ready to write our augmented matrix. 2, 2, 2, 6, -3, -4, 5, -2, don't forget your colons in here. I kind of left space for it but didn't put it in there. And then finally 5, 5, 5, colon 14. We want to note that this is also a 3x4 matrix. 8, -4, 6, 30. This one is in standard form. I didn't say that, but it is. Remembering to put ones when you don't have a different coefficient. Oh, and remembering to put zeros when you don't see the variable at all. We have 0 z's here. Bracket that off as a matrix and note that it's 3x4. Our very last one now, we have 3, 1, 1, -9, -6, -5, -8, 0, 2, 3, -1, and -11. And we will note that this is 3x4. Now I want you to meet me over at desmos.com/matrix, and we will input these matrices and see what we come up with for solutions. All right, everyone, so here we are in Desmos. Remember that this isn't the regular Desmos that you're used to, the graphing calculator. This is desmos.com/matrix. So be sure that that's where you're at. And we want to create a new matrix. So we're just going to click New Matrix. It just calls it Matrix A. That's fine. The first thing that we need to do is edit the number of rows and columns. Right now it only has 2 rows and 2 columns. So we want to increase to 3 rows and 4 columns. Remember we said it was a 3x4 matrix. And so this gives us spaces to put all of our variables in. So you're just going to put in the number, and then you can either hit the little forward button, you can hit the tab key on your keyboard as well to advance if you don't want to be using a mouse or keyboard to navigate. And I'm just going across and putting in every single number. We don't put the colons in here. This is what makes it an augmented matrix, is we're doing just the equations, but then we're putting the other side of the equal sign on there too. So augmented means to enlarge or increase the size of. Let's go ahead. -3, 4, -2, and 1. You want to be really careful that you're catching all of the positive and negative signs. So at the end, once you've got this all put in, take a glance back at the augmented matrix that you entered and just make sure that it all looks good. Then you're going to hit the enter key, and again on your keyboard or this enter key. And then the next step that we want to do is we want to hit the button that says RREF down in the lower left. That stands for Reduced Row Echelon Form. We want the reduced row echelon form of what? Of matrix A. So we want to select A. And now over on the far right, you can see that we have our reduced row echelon form of our equation. Now that we have our reduced row echelon form over here on the right, we can interpret it and decide if we have a solution or not. So notice that we have that diagonal row of 1s here, and so that means that we do in fact have a solution, and our solution is going to be -3, 1, 6. For problem number 10, I've gone ahead and typed in all of the elements of our matrix into matrix A. Once you do the RREF, the reduced row echelon form of A, you're going to get this reduced row echelon form here on the right. Now remember that we are looking for a diagonal row of 1s right across here, and ooh, I don't have a 1 there, I have a 0. So this line right here means that 0 is equal to 1, and that is a false statement. When you have a false statement, it is no solution. Let's take a look at the solution for problem 11. Again, I have already introduced all of the elements of my matrix A and done the RREF calculation on it. Here is my resultant reduced row echelon form of my matrix. Remember that we're looking for a diagonal row of 1s, and this time we have it. So that means that the vertical row is in order X, Y, and Z. So our answer is 5, -2, and -3. Last one, let's look at problem number 12. Again, I have already put in all of the elements of my matrix into matrix A based on the steps we did back in problem 9, and I've done the reduced row echelon form to get this matrix. Looking for a diagonal row of 1s, and again I am able to find it, which means that this vertical row is in order my ordered triple, -4, 0, and 3.